Click the bell icon to get latest videos from Ekeeda.
Hello friends, now we look at the traverser of the red black tree. That is how we are going to traverse the red black tree. We have three formats for traversing of any tree. These are in order, pre-order and post order. In similar pattern, we are going to follow this tree structure for traverser. Let us begin with the topic. I've defined a function called as inOrder. Inside that I've written inOrder header dot write. That is, we are going to recursively call the function through header dot write. We are going to call the function inOrder red black node root r. When this is done, that is root values taken, then we need to check whether the root is null or not. If it is a null node, what does it means is that there are no value present in the given red black tree, so we cannot traverse it. So we need to check whether the root is null node or not. We write down if r not equal to null node, then we move to the left hand side, hence we write down inOrder r dot left. We go for the left hand side, then we put it the color. How do we put it the color? Char c equal to b, that is b will be taken for the black. If r dot color is equal to 0, what does it mean? The color has the value 0. We have put up the value for red and black. Okay, so we write down if r dot color equal to 0, in that case c, that a character value will be r will be for red color. So you must remember, in case of red black tree, all the nodes have either red or black color with itself. Then we write down system.print r dot element, that the root value is taken and its color is taken from this value. It is going to be either black or red. So for the root element, it is always going to be black. You must remember, in case of red black tree, every time of the red black tree, the root node is always black. Then we go for the right hand side. We write down inOrder r dot write. This is the value for the right hand side. This is the inOrder traversal. Then we move for the pre-order traversal. We call the function pre-order header dot write in the similar pattern of inOrder header dot write. Once we are done with the inOrder, we move to the pre-order. Again, we are going to check for the same set of conditions of the root, that is whether it is null node or not. We write down if r not equal to null node, in that case char c value will be b. B will stand for black. Then we will check for the condition of the color, that is if r dot color equal to 0, then it will be red. Hence we write down c equal to r. Then we print the value of root element. We write down system.print r dot element c. C is the value which we are going to take. Then we go for the left hand side. We write down pre-order r dot left. First we will go for the root node, and after that only we will move to the left hand side. And in the similar pattern, once we are done with the left, we will move for the right. We write down pre-order r dot right once we are done with the left. Then we move for the post order traversal. In this case, we write down the same set of functions, that is post order header dot write. Then we go for the post order function. We write down private void post order red black node r. If it is not equal to null node, then we will first move to the left hand side. Hence we write down post order r dot left. Then we move to the right hand side. We write down post order r dot right. Then only we will go for the root node. For this we have char c equal to b. B is for black. Then we will check for the color. If r dot color equal to 0, then in that case c will become red. Then we write down the element, that is system.print r dot element plus c, that is going to concurrent with the c value. It is going to be either black or red depending upon the values which are going to traverse. Once this is done, then we will start with the definition of the red black tree. We write down public class red black tree test. Inside that we take the main method, in which we have the scanner class object scan, which is to take the value from the user. Then we will start creating the object of red black tree, which is rbt equal to new rbt. Inside that we have integer dot minimum value. This is very important. We need to call the function of integer dot mean value. That value will be given to the rbt object. Once this is done, then we write down system.println red black tree test. Then we have the character, which is ch. Once we are done with this, we will start with the tree operations. We write down do, then we give him the user the set of operations which he can perform. 1 is for insert, 2 is for search, 3 is for count node, 4 is for check empty, 5 is for clear the tree. Then we take the value from the user which set of operation he wants to perform in the variable choice. Then we will go for the switch case, which is switch choice. First case is the insertion. For this, we are going to call the function called as insert through the object arbitrary. You must remember all the objects are there, but out of that we are going to choose the object of arbitrary which we have defined, in which we have put up the value, and based on that we are going to call the respective set of function. For insertion we are going to call insert, which is the case number 1. Case number 2, we call the function arbitrary dot search. Inside that we take the value. For case number 3, we call the function arbitrary dot count nodes. These are the 3 basic cases. Let us move to the another set of cases. For empty status, we have arbitrary dot is empty. Then for case number 5, we have tree clear, in which we are going to make sure make t empty. That is, make empty function is called through the object of the arbitrary. That is arbitrary dot make empty. That is going to make sure the tree is cleared up of all the values. That is, we are going to have the root node as equal to null. Once this is done, then we start displaying the tree. We have system.out.println post order. Then for this we call the function arbitrary dot post order. For pre-order we call arbitrary dot pre-order. For in order we call arbitrary dot in order. This is how you call the respective set of functions through the objects of arbitrary. Then we are going to ask the user whether he wants to continue with the same set of operations or he wants to stop. For this we are going to give him the set of choice. For y, yes, and for n, no. If the user enters y, then we are going to give him the same set of operation. If no, then we are going to stop the program then and there only. The user is provided with the set of operations he can perform on the red black tree. We will go one by one. Let us start with the first set of operation, that is your insertion. As you can see, I have entered the value 10 and pre-order, post-order and in-order traversal are given for this set of value. You can see in the output comes at 10B, indicating that 10 acts as the root with the color as black. Let's go for the same set of operation with another set of value. As you can see, our tree now looks like 10 is the root with color black and 20 is its child with color red. Let us go for same set of operation with another value. Now we have entered the value as 30. So our tree now looks like 20 act as the root now, which is of the color black, and 2 other values 10 and 30 are its child with color red. This is how you design the red black tree. Now we will go for the another set of operation, that is operation number 2. The user is asked to enter the element to search. Let's search for value 10. As you can see, the search result comes out to be true, indicating that 10 is present in the given set of graph, that is given set of tree, and its pre-order, post-order and in-order traversal is also shown. Let's go for another set of operation. The next set of operation is to count the number of nodes. We have entered 3 values named as 10, 20 and 30. So our count comes out to be 3. Let's go for another set of operation. The another set of operation, that is operation number 4, is to check whether the tree is empty or not. In this case, we have 3 values named as 10, 20 and 30. So our empty status should be false. Let's check with the value. As you can see, the empty status comes out to be false with its predefined values of the traversal, that is in order, pre-order and post-order. Let's go for the another set of operation. The another set of operation is to have the tree cleared from all its sets of value. Let's clear up the tree now. As you can see, the tree is cleared and there are no value to be shown to the user for the traverser. So our in order, pre-order and post-order comes out to be blank. You must remember, in case of red black tree, we have alternate colors of red and black. The root of the tree is always black. Thanks for watching this video. Please subscribe to Ekeeda channel.